In this video, we're going to work our first line integral problem. So let me set it up. The temperature of the circular plate. So we have a circular plate down there. You can see it in the picture, that gray plate at the bottom here. Right? We have a temperature of plate, and it says the temperature of that plate. Notice that they said less than or equal to 1 here for this circle of radius 1. That's the whole disk. That is a thing that we work with in math as we go up. So the temperature of that path they are given here. You give your xy in that disk, and I'll give you the temperature. They want to find the average temperature, though, along the edge of the plate, not the whole plate. So we can't use this as our R. We got to come up with a path that goes around a circle with radius 1. Well, this is just our unit circle. So our path, if I want my unit circle, remember our x is just going to be cosine theta, because it's x, right? Sine theta for y. And then I just run that from 0 to 2 pi. They're wanting the average temperature. It says find the average temperature along the edge of the plate. So when I do average, I don't know if you guys remember, we have to divide by the length. So the length of path, well, that's just all the way around with a radius of 1, so it's 2 pi, right? That's the circumference of a circle, and you could do it this way too, use the formula 2 pi r, but r is just 1, so we get 2 pi. So I have r, I'm working up, I have this definition of a line integral. This is how we can get the measure that the sum of the whole, of all the temperatures on the outside of that disk. We use this formula. So I got to work up to that formula. I have an r, I need an r prime. So if I take the derivative, I get negative sine theta, cosine theta. And then they want us to take the amplitude of that path, of the derivative. So if I do that, that's just squaring each one. You can see that this is going to end up being a 1. All right, no surprise there. It's a unit circle. The magnitude is 1. All right, so I have that. I also need f of x of t, y of t. Now remember, this just means put it in terms of t. Well, if you're wondering where what of our formulas are, I'm going to write that right above it. X of t, and this just comes from right here, right? Cosine, I guess we should have used t's instead of thetas there. Just staying with the definition, sorry about that. That means also these are t's as well. So x of t is cosine t, y of t is sine t. We got that from right here. That's how we defined our r. That's x and y. So I'm going to plug that into the formula up here, right, for temperature. So I got 100 times x squared, which is just cosine squared t, and then plus 2 y squared, which is sine squared t. Now this kind of kills our Pythagorean theorem. If that 2 wasn't there, I could just say that's a 1. Here's a little trick that we can use to simplify it, because I'd rather not have cosines and sines. So what I can do is I'll do cosine squared t plus sine squared t plus sine squared t. If I add the sines back together, I get the 2. This now is equal to a 1. So this is equal to 100 times 1 plus sine squared t. I know that sine squared is going to create a problem. Let me fix my handwriting a bit. It's getting a bit sloppy. My natural handwriting is extremely sloppy, so when I'm teaching, I have to try not to be so bad. So 1 plus sine squared. You guys know that at this point. This is equal to, this is using a trig identity. This is equal to 1/2 times 1 minus cosine 2t. That if I keep the square, it's going to cause a problem in the integral. I'm going to do this eventually anyway, so I'm just going to do it now. So I got 100 times, okay, I'm going to get, if I distribute that, I'm going to have 3 halves. That's the 1 plus 1/2, the multiplication here. I'm not just adding the half. I'm thinking about if I multiply the half times 1, I'll get 1 plus 1 that, and then I'm going to have a minus 1/2 cosine 2t. That's our temperature there. Okay, I'm going to shrink this up quite a bit because I need room to do an integral. All right, so my integral for average temp, I'm going to put t with an average. T average is going to be 1 over 2 pi. That's the dividing by the length. And then it's going to be from t equals 0 to t equals 2 pi. We grab that from right here. And then I put that, it's going to be this, right? times this, dt. Well, that's just a 1, so that makes our lives very easy. We get 100 times 3/2 minus 1/2 cosine 2t dt. All right, I'm going to, I guess, factor out all numbers. How do I want to do this? I think I'm just going to leave I'll take the 100 out. 100, we get 50 over pi. And then our integral will still not, we can go ahead and integrate. Let's do that. So if I integrate now, okay, I get 3/2 t minus, okay, I got 1/2. And if I integrate cosine 2t, I need to make sure that 2, it's going to be a sign for sure, and the sign is going to change. And then I have to think about how that's going to, when I take the derivative, I'm going to get a 2, so I need to cancel that out, so I'm going to put another 1/2. Now what I do to make sure that I'm correct, I take the derivative of what I just wrote down. Derivative of sine, oops, and then see I messed up the SIGN. It still needs to be a negative. And then if I take the derivative of sine, I'm going to get the cosine. And then derivative of 2t is 2. That's going to cancel with that, leaving me with what I needed. If you can't see that, that's okay. Use a U sub. All right, so I plug all this in. I can see that if I plug in 0, it's going to make 3 over 2t 0, and then sine of 0 0. So all I got to do is plug in, it's 2 pi. So it's going to be 3/2 times 2 pi minus 1/4 times, and this is just going to be 0. It's 4 pi, sine of 4 pi is 0. Plugging zeros makes it 0 out, leaving me with, okay, I get, those 2's cancel, I'm going to get 150. I think that's it. The pi's cancel, the 2's cancel, 50 times 3 is that. And I think this was, they didn't even give us, is it in degrees or anything. It just says find the average temp. So I'm just going to leave 150. I don't know if this is Celsius, if it's Fahrenheit, but I at least could find the number.